on our 211. 211 should have been the easiest homework you've had in quite some time. People that did it, if you agree with me, nod your heads in agreement for people to look at you that didn't do it yet if they didn't. So the first, number one, we want to have a list of the degree for each term and then a grand total degree. If you even didn't do it, just join us on 211. I think I'm going to declare everybody take a turn, we'll come around sort of thing, so just be ready to do our turn. Let's get volunteer to talk about one while people get organized on that page. Do you have it? Crash papers.
Someone doesn't have it.
Get those later. Okay, and then the grand total is 4. So number one, our degrees of the terms would go a 4, a 3, a 2, a 1, and a 0. And then the grand total degree for the whole thing is 4. Does anybody need an explanation for how that just happened? Okay, so try to just, if you didn't do this, count around the room and figure out which number you're going to be. Keith just did 1, so we'll pop up a person for 2. Can you spontaneously do 2?
6.
3, 2, 1, 0.
And grand total?
3.
Agreed. Number 3?
3, 6, 6, 0.
Grand total?
6.
Agreed. 4?
2, 5, 7, 0, 7.
Correct. 5?
5, 6, 2, 1.
And then a 0. And then grand total?
6.
True. 6, just spontaneous?
I think it's gonna be.
Just go each one at a time. Like the first one's
A 6.
6, then
4.
not a 4.
8.
Oh, an 8. Oh, we're counting the O.
Okay.
6, 8, 4, 2.
Yeah, agreed. Last one would be
0.
0. And then the grand total
8.
is 8. Anybody 1 to 6 trouble with those list making skills?
Oh, this is so easy.
That's what I was saying. That's why everyone nodded their heads in agreement. 7 is just combined like terms. So 7, what do you say?
3x 2y minus 5xy squared plus 7xy plus 2.
All true. 8.
2x squared y minus minus 7xy squared plus 8xy plus 5.
All true. 9, they gave us 3 of them.
So 3x plus 2y minus 2z minus 3.
Correct. 10, they gave us 3 of them. Go a little bit slow because my book doesn't have answers. I'm having to do these in my head while you're reading.
7x squared
Yep.
minus 2x
Yes.
plus 11y. Oh wait, no.
No, that.
Plus
Wait.
minus.
Not everything has a like term friend. You got the meanest one so far because some things have a match and some things just get copied. So like the y's, you'd want to just copy the minus y because there is no other thing with just a plain y.
Oh yeah, I forgot to write the 12 as the xy.
Okay, yeah, so the 12xy, you copying that or does that have friends?
You just copy.
Just copy it, so a plus 12xy gets copied. How about your x's? Just the minus 2x copies, and then the numbers you'd have to do some work.
Minus 9.
Minus 9. Decimals, what do you say?
9.46
Yep,
plus 2.50 y
yep,
plus 11.8y.
not quite. Small mistake, it's the most common mistake in the world of math. Be a minus there. Be a minus 11.8y.
I don't think it was 3.
I agree. Uh-oh, fractions. You okay with that one?
That's the one I didn't do.
Okay, we'll pop up a person. You okay with the fractions there? Okay.
Half x to the third.
Yep.
Minus 3 times x to the third.
Yep.
Minus a fourth x squared.
Yep.
Plus 2/3 x.
Yep.
Minus 19.
All true. Then let's cut back to you for 13. You good on 13?
Okay. Negative 5x to the third plus 7x squared minus 3y plus 7.
It's a 3x plus 6, but yeah, it just right thing, just a little bit of a sloppy letter maybe. 14, you good?
Is it positive 4y plus 7? You want me to add this one?
No, you're just having to switch all the signs. Just
Okay.
distribute the negative, the signs all turn.
Yeah, then negative y to the second, then plus 2y, and then minus 4 plus 1.
I think so. 4y to 4 minus 7y to the 2 plus 2y plus 1. Volunteer 15. Yep.
Negative 2x squared plus 6x minus 3.
Correct. That's probably the hardest section because you have 2 steps. You have to change all the signs of everything on the right, and then you have to combine. And if you miss a sign, it's going to mess it up. 16 has a 4-term answer. Anybody 16, 4-term answer?
Negative 4x squared plus 8xy minus 5y squared plus 3.
Agreed. 17 will have a 3-term answer.
Negative 4a squared plus 8ab minus 5b squared.
Agreed. Do you want to go 18?
6x to the 4th
Yep.
plus 8x squared minus 9x. I get switch.
Yeah.
6x to the 4th minus 8x squared plus 9x minus 4.
Yes, sir. Anybody 211 need any help from me? If you did it, you probably enjoyed that. If algebra can be enjoyable, because that was a pretty quick hit. If you didn't do that, just play a quick catch up. That was a pretty good homework. This homework's going to be a little bit of an upgrade in difficulty and length, but this one's not bad either. The homework tonight is going to be, I'm going to say 90% stuff you've done from Algebra 1. We just have to remind you. So if homework's done, send it down and we'll just jump right in. So yesterday we added polynomials. Yesterday we subtracted polynomials as well. Today we're going to multiply polynomials. So I'm going to start with the worst one, do some easier ones, and finish with probably the second to worst one. But starting with this worst one, does anybody remember how to take on this worst one of the day?
Take the 3x and multiply it by every piece in the first fraction.
Okay, so the 3x has to multiply every piece from this, that's true.
The 4 has to multiply every piece.
4 has to multiply every piece of that. That's one way mentally you could think about pairing these off is focus on the 3x, get everybody, focus on the 4, get everybody, that would be fine. You could also focus on 4x squared and get both of these. The 3x, get both of these. The 2 gets both of these. It doesn't really matter what order you pair them all off in, you just have to make sure you get every pair. So if 3 items multiply 2 items, how many items would we need to create?
6.
6. Because
3 times 2 is
3 times 2 is 6. If I wanted to be mean or do a crazy extra credit question or something, if I did a 5-term thing times a 4-term thing,
20.
you'd get 20 terms. Is it going to stay 20 terms? Stay those? No. What's going to probably happen once we create them? We're going to probably want to combine them down. I would suggest you try to do this in some sort of an orderly way. Okay, so Aubrey had an orderly suggestion of start with 3x, get everybody, then go 4, get everybody. That's fine. I would personally have gone 4x squared, get everybody, 3x, get everybody, 2, get everybody, but we're both right. It doesn't really matter what your taste or style is on that. But you want to do it in order. Because if you start to be like, oh, I'll get these 2, I'll get those 2, I'll get these 2, wait, which ones did I get? Like you're just going to get lost in the shuffle. So Who's your idea? Go ahead, why don't you start with this and just get me everybody.
12x cubed
Cube,
plus 9x squared plus 6x, and then it's plus 16x squared plus 12x plus 8.
okay, why did I write it the way I wrote it and not just keep writing across while she talked?
Makes it simpler, like, on
Yeah, I lined up who?
the,
I lined up my like terms, just to make my job long-term easier. You don't have to do that, that's what my preference is to do, so I don't have to skim later. If there's 6 of them, is that a big deal? Probably not. If there were 20 of them, that'd probably be a big deal, because we'd be like scanning all over the place. So final answer off of this is 12x cubed plus 25x squared,
18x.
18x, and 8. Remember, when you're adding and combining at the end, you don't change the variable counts on the exponents. But when you're multiplying, what do we do to the exponents as we multiply?
Keep them.
Not just keep them.
Oh, yeah, add them
These have invisible
on. One.
ones, so sometimes the 1s and the 2s are how we get 3s, or 1s and 1s create 2s. But we add exponents when we multiply, but when you come to combine, you just keep them. Question about that? My best way to explain this is probably that it's like multiple distributing. If I just gave you this problem, you would distribute. 4x squared would get everybody. But there's also this to get everybody. There's also that to get everybody. It's just like a triple distribute move in a sense. Or if you look at it Aubrey's way, it's a double distribute move. She distributed that one. She distributed that one. It's just like distributing on steroids. It's all this multiplication of polynomials. Question about that? This, if we do this, a binomial with a binomial, there's a famous algebra acronym that people use to just help you, but it's the same concept. The famous acronym is FOIL, where the F stands for
Factor.
firsts.
Oh.
Who are the firsts? A and C. So A and C are the firsts. O?
Outside.
Outsides. Who are the outsides?
A and B.
A and D. I for
Inside.
the insides are B and C. And then the L
Last.
for last, which is B and D. Nothing here is like, so we're just done. You don't have to like follow OCD style the acronym and do them in that order. All this acronym does is try to give you a guaranteed way that you've got every pair. Okay, but the same idea applies. If A multiplies both and B multiplies both, you're good. Or if C multiplied both and D multiplied both, you're good. It doesn't matter what order you put them in, but this is just a handy acronym, I think, for beginners to understand. I've got to get them all. And if you FOIL and get 4, you got them all and you're good. Sometimes people will still refer to this as foiling. I don't know that that's accurate because there's too much stuff. You need a 6-letter acronym. I don't see the point in creating one right now. But the concept is make sure everybody multiplies everybody. So here, 2 terms, we're going to temporarily get 4 terms. What's one of those terms? X squared is in there. 3x I don't want to write down yet. 4x I don't want to write down yet because 3x and 4x together is 7x. If you need the comfort of writing down the 3x and writing down the 4x before you combine them to make 7x, absolutely feel free to do that. I'm just old and grouchy and don't like to write stuff down anymore if I don't need to. I'm going to just hold the 3x, I'm going to hold the 4x, I'm going to just make them 7x in my mind and write them down. And then there's a 12. I'm not saying you shouldn't write it out, you make your own choice. If you can hold stuff in your head, do it. If you need to write it down, write it down. You decide what you want to do. I've decided what I want to do. I'm not writing it down. Okay, but the 3x and the 4x, that's where the 7x came from. Question about that. So next one, something.
2x squared.
2x squared, write it down or hold it? Let's write it down. There's nothing else that's going to get an x squared while we do this. 6x, write it or hold it? Hold the 6x. Who's 6x's friend?
5x.
The 10x. So 6x, 10x, 16x, 30. Question about how that was going in the world of foiling. So the first time in your life you see a plus b squared, you probably write more stuff than where I'm ultimately going to steer you. But if we want to write maximum things down, what does a plus b squared mean? What's a way we could do this that's going to involve some writing?
A plus B equals AC.
Take a plus b and put it next to a plus b. And then let's FOIL that. So what's a thing we get?
A squared.
There's an a squared from the beginnings.
AB.
There's an ab from the outs.
There's a BA.
There's a ba, which is really the same as an ab on the ends.
B squared.
And then there's a b squared. The ab and the other ab would make a total of
AB squared.
Two AB.
2 ab's. So we'd have an AB, because there's a 1 in front of it, like a 1AB and another 1AB. We could make 2AB. That's our way we could do this with more writing than I would choose to do, but you can choose to do it. I'm not like objecting to you doing whatever you do to get a right answer. But a plus b squared, you could write doubles and just FOIL it out with whatever writing you need to do. But these would make a squared, these would make the b squared. That's one of the ABs, the second AB, now I've got 2 ABs. Question about doing that? If you need to show those steps, show those steps. If you need to show more steps by writing the AB and the AB before the 2AB, write all those steps, that's fine too. I don't do this way, I do this by pattern. In the next couple years of your algebra life, you're gonna square out a ton of stuff. Okay, not as much as I have in my lifetime, so I've been doing this a long time, but I'm just gonna go by pattern. I just know from doing this over and over, the A is gonna have to multiply itself. So just put a squared. The B is gonna have to multiply itself. Just put down a B squared. That will always be a positive, because a positive times a positive is, but a negative times a negative, also positive. So no matter what, when we do these squares, this is positive, this is positive. First has to multiply itself, last has to multiply itself. I start with those in my mind. In the middle, you're always going to keep the sign. These have to multiply each other, but there's always going to be 2 of them. So A times B, but there's always going to be 2 of them. So if I have to FOIL this, I'm going to go x times itself, guaranteed positive. I'm going to go 3 times itself, guaranteed positive. I'm going to peek to the sign and keep it. These multiply each other, but there's doubles. So not 3x, it's going to be 6x, because we've got to double that middle thing. Question about that. If you're squaring, you're always going to multiply 2 items. And in the middle, times 2. That's what that's just going to do to you. If you hated that, listen to me 2 more times to see if it grows on you. If you still hate it, don't ever do that. And just write doubles and FOIL it out. I'm not criticizing that at all. I'm just saying if you want to do this the fastest way possible, just do what I'm doing. Okay, so again, patterning is first thing times itself, guaranteed positive. Last thing times itself, guaranteed positive. Middle sign is a copy. Multiply the twins, A times B, but there's always going to be 2 times that amount. Every time. Question about what I'm doing with pattern? So what will we start with first item because of the 2y?
2y squared.
Close? 4y squared. If we take the 2y times the 2y, that's going to get us a 4y squared. Then I usually cut to the end, the 5. 25. Sign on that,
Positive.
always positive. Middle sign,
Minus
minus. These, when these hit with each other,
20y.
20y. 5 times 2 would get us a 10y, but always there's twice as much as what that initially gives us. 10 times 2, there's a 20y. If that grew on you, use that. It's quicker. If that still is hated, no, don't do that, that's fine. Just write twins and FOIL it out like you were FOILing out in the other corner. Question about squares? I'm gonna do this one a long way, and then I'm never gonna do it the long way again. If you wanna do it the long way, you can do it the long way, but not gonna happen in my life. Okay, so if we FOIL this the way we did the corner, what's a thing we're gonna get?
A
We're
squared.
gonna get an a squared. What's another thing we'll get? A negative b squared is common.
Positive AB.
A positive ab is common.
Negative
A negative ab is common. And for the last like 10 seconds, we were just wasting time because
You didn't have to write the A.
we didn't need to write those ABs. There's a positive AB, there's a negative AB. Those aren't gonna do anything other than disappear anyway. So why even put them? If you notice that the factors are almost twins, but they have different signs, just do first one times itself, point, last one times itself, there, and that's always gonna have a minus sign. If these signs are different, when signs are different, the stuff's always negative. So go first times itself, minus, last times itself. So here's a question like that. The x will turn into x squared, guaranteed sign, and then the 2's squared. If you want to FOIL it, you FOIL it. I'm not going to do that. What if I threw a 7 and a 5? Could I do that? No, because they need to be same. If I throw 7's, now I've got 49. If I threw an A and a B, can I do that anymore? No, because they're not the same. But if I did a B and a B, that's B squared. Okay, only if these are the matching stuff, except the signs, can you do that trick. Okay, if it's completely different stuff, there was no shortcut over here. Okay, there's no shortcut to basic form. But over here, when they're twins, perfect twins that are squaring, we've got the one pattern. Almost twins with different signs, we've got a secondary pattern. Question about that? Then we'll finish with the second hardest thing of the day. So that was the first problem we did, is probably the biggest problem of the day. This is the first one you've never done before. I don't think you've ever cubed anything in Algebra 1. So there's two ways you could do this. What's one way you could do this that might feel familiar to more people?
Do what you did.
Do what we did over there, but we copy down a plus b 3 times. I'm not going to do this way, but if you're patient, you could do this. Okay, so you could copy down triplets of the a plus b, FOIL 2 of them, get an answer. Take that answer, FOIL the other one. Okay, patience and peck away at it, that'll work. You'll be fine. I don't wanna, okay, but that can work. Question about how you could travel that road, but I'm not gonna travel it. Here's the road I'm gonna travel, is I'm just gonna work off of a pattern. I'll make an analogy back to this one. When we squared, we always multiplied two things. When we started to do like one of each thing, we also had to multiply by 2. Okay, so squaring multiplies 2 things. When we start to mix and match, we had to multiply by 2. So if you're cubing, it stands to reason you probably should multiply 3 things, but when you start to mix and match them, you'll multiply by 3. Okay. So one way we could get a triple multiplication would be A multiplying A multiplying A. What's A times the A times the A going to be?
A cubed.
A to the 3rd. B. We could do B times a B times a B. So I'm going to finish with B to the 3rd. Then there would be some ways to mix and match these, but I'm going to have to get 3 of each of those. Okay?
3 AB.
I could get an A with an A with a B, which makes
A squared B.
agreed. Or I could get
B A.
BBA, which would be
A B squared.
I'll run through another one like that I shouldn't have erased this, I was a little premature. But if we did try to do this crazy FOIL, one thing you'd have to hit would be like an A with an A with an A. We did that. You'd have to hit an A with an A with a B. But we'd also need this A with that B. And you'd end up with like 3 of those duos. If you tried to match everybody up with everybody, you're gonna get 3 of stuff. You could get A with B with B. You could get A with B with B. You could get A with B with B. It's a lot of stuff. There's 3 of them. It's always gonna be 3 of them. I'm just gonna clear that out now. Let me rewind. So what we did if we lost people, cubing, you're gonna always try to multiply 3 things. So A, we got it. B, we got it. A, B, we sort of got it, but there's 3. Anytime we're using sum of each, there's going to be 3 of those guys. And then there's also a B, A, which we got, but there's 3 of those guys when you start to get a little bit of everybody involved. Question about that? Okay, so here we need to go 2x times 2x times 2x again. That is 8x cubed. At the end, 3, 3, 3. 27. If everything's positive, everything's going to be positive. I'll switch to a negative in a second. Question about beginning and end, that's a little easier. Then go this times itself, but also times the 3. We need to get 3 items to multiply. So this times itself times this. What's that so far? 12x squared. 2x times 2x is 4x squared. This would get us to a 12x squared, but when I write down, I'm not going to write down 12x squared. 36x squared, because when I'm doing some of this and some of that, I have to multiply by 3. What's my last pairing? Who, and who? 3, 3, and 2x. 3 times 3 times 2x, 18x, but I'm not going to write down 18x. I have to remember, multiply by 3, 18 times 3. 54. If that blew you away and you're like, I don't think I can do that, then don't do it. Or in the homework, try it, see if you can get the hang of that. Your safe play that everybody could do, if you're patient enough, is just write 3 of those side by side, FOIL 2 of them, get an answer, FOIL a 3rd time. I just don't want to. I don't want to do that. There. If I go like this, are some of them negative or all of them negative? What's up with that now?
Would it be all of them but the 36x squared?
No. Won't be all of them.
Would be everything but the first one. The first.
So let's think about where this came from. So at some point we did a 2x times a 2x times a 2x. So that negative 3 didn't even factor into that one. So the 2x leaves who unchanged? The 8x cubed has no reason to change just because I changed the sign on the 3. Okay, another place we did this times itself times itself. We hit that 3 times.
So that one would be.
So that one would be negative. Where did that one go?
At the end.
That's at the end. So this would go negative. Then there was another one we did 2 of the 2's, 1 of the 3's. So if we do 2 of the 2's, 1 of the 3's,
That's negative.
that's negative. Where did that one go?
That's the 30.
That's the 36. And then the other spot, we did 2 of the 3's, 1 of the 2's.
That's positive.
That's positive, because 2 negatives makes a positive. That's where the 54 was. That sits. So if I switch to a negative sign, it's going to switch half. And if you go in if everything's in descending order, if the problem is in descending order, and you keep your answer in descending order, the signs are going to alternate. And that would be another just quicker way to maybe even do that is, just make sure your problem's in descending order. Make sure your answer's in descending order, and then just alternate the signs. That'll be fine. That'll happen every time. Question about foiling, aka multiplying polynomials, because technically this is not foiling, but people just call that foiling, and that's okay. It doesn't hurt anything. We know what each other mean. But anybody question about things? Number one priority of the day is make sure everybody gets an opportunity to multiply everybody else. So if it's 3 times 2, make sure you get 6. Everybody multiplies everybody. Binomials, you get 4 and then you narrow it down. If you're cubing, you're going to have to do 3 multiplications at a time. If you're doing squaring, you're going to have to do 2 multiplications at a time. Just make sure you get everybody and be a little bit like, what's the word I'm looking for? Orderly, organized, something about how you approach it so you just don't get lost in the stuff. Where we are, homework and stuff, we're 216, we're 1 to 28. It's basically laid out in the order that I laid out my examples. So if you're wondering, like, why did I do the hardest one first? Well, it's what the book did. Why did the book do the hardest one first? I don't know. I didn't write the book. You'd have to ask them, but they're probably dead by now. But 216, the first 6 are like this, that you're going to get 6 terms or more. I think there's one that has 3 terms times 3 terms. So 3 terms times 3 terms, you temporarily get 9 terms, and then whittle it down. But first 6 are more like those. Then there's some straight foiling for a handful of problems. Then there's some squaring for a handful of problems. These I'm going to call difference of squares problems. When we start to reverse this process, that's a name you're going to need to know. Difference means subtract. So if you're subtracting squares, that's called a difference of squares. When these factors are almost twins, you're going to get a thing called a difference of squares problem answer. And then it finishes with the cubes. There's 4 cubes at the end, but we're going to 28. If you get a perfect paper, you're smarter than the book, because on one of their cubes they forgot to alternate signs and they got a mess up on one of theirs. So if you get all the cubes right, you're smarter than people that wrote a book about it. Anybody 216 looking at it thinking, wait a minute, I don't think I know how to do that one? There's only 2 with fractions, so that's good news. There's none with decimals, that's good news. They mostly stuck to whole numbers that were like 5 and under, so that's all fairly good news. All right, that's all I got.